Okay, contoh you have this phase diagram, and then you would like to choose one. You will discuss a lot different condition during the transformation from liquid to solid. Okay, for example, in this example, let me choose, for example, the 20% of alloy. Okay, this is the alloy. You need to choose alloy. One alloy, for this alloy, it consists 20% of zinc plus 8% of aluminum. So why you choose this one? Because it shows a transformation from liquid. Okay, this is liquid, and then liquid plus alpha, and then alpha. Lastly, at room temperature, it will show alpha plus eta. Okay, so there are four phase transformation. Okay, four from liquid, liquid plus alpha, alpha, and alpha plus eta. And then maybe the second alloy shows a different transformation. For example, 40% ox. Okay, for example, the 40% of zinc. Okay, so because why? Because it shows a different transformation. The difference is it shows alpha plus beta phase transformation. Okay, now how to determine the temperature, right? Yeah, your question is how to determine the temperature.
Yes. Specific weightage.
Specific weightage.
Maksudnya macam
okay. Soalan tu macam mana? Okay, so the objective, I will, okay, sorry, saya buang masa benda yang you dah tahu. Okay, question yang tanya what is a weight fraction weightage or weight percentage or weight fraction weight fraction tu kan, which is W simbol W ataupun M. Okay, this value, how to determine temperature? The objective of this, okay, is we would like to know whether or not you understand how to determine weight fraction at specific temperature. It can be any. It can be any. So that it can be any temperature, but of course we need to select. You need to wisely select the temperature. You cannot select temperature. For example, let's say this is your alloy, 20%. You select temperature at 400. Okay, 400. So 400 is only alpha. All right, so you cannot determine weight fraction of phases present at that particular temperature, which is 400. Why? Because there's only alpha. So mean the weight fraction of alpha is 100%. So there's no I cannot assess your knowledge on how to determine the fraction phases. So you need to choose temperature. For example, you can choose 600. Okay, why 600? Because 600 contains two phases, which is alpha and liquid. So just take one temperature, 600. Boleh?
Kalau kata saya nak betul-betul atas line yang liquidus line tu, at 20%, betul-betul dekat point.
Dekat, misal kata ni, temperature ni.
Ya. Macam mana kita tahu temperature dia?
Okay, nak tahu temperature dia? Macam mana nak tahu temperature dia? Saya tak faham soalan awak. Awak nak tahu temperature ni?
Temperature at that exact point. Yes.
Macam mana, kenapa tanya saya macam mana nak tentukan? Baca je lah dekat Pak CY tu.
Saya dah cari dia punya skill tak jumpa. Yang...
Okay. Saya faham. Awak nak pastikan dapat betul-betul exactly value temperature tersebut?
Yes.
Tak payahlah. Maksudnya kan macam ni kan. Saya tengok ni saya tahu dah. Okay, fine. It is about 620 ke 650 ke something like that lah. Faham? Okay,
so untuk dalam temperature curve tu kita just estimate je lah?
Estimate. Because you nak bagi exact value kan. So you kena estimate je lah. Kalau tak, you ni untuk the direction for you to sketch the cooling curve, isn't it?
Yes.
Okay, the cooling curve. So let's say lah, you tak jumpa exactly first diagram yang sesuai, macam tak nampak dia punya scale dan sebagainya, tapi scale tu you boleh create. Maksudnya you boleh transform this diagram into any application ke any software yang boleh bagi exactly grid maksudnya lebih accurate lah you nak tentukan apa bacaan pada pasir Y itu. So this diagram boleh masukkan dalam grid pasir XY tu, nanti dia boleh tentukan. Tapi kalau you malas nak buat benda tu, you boleh just label with symbol ataupun letter lah ataupun numbers. For example, you letak sini T1 and then somewhere point here you nak analyze ke ataupun kalau dia relevant you boleh letak T2 and then you boleh letak T3 and then you boleh letak T5 somewhere here and then room temperature T6 of if it is relevant for your thesis lah. If you just want to sketch a cooling curve, I think you take any intercept lah. For example, let's say this alloy, you take T1, T2, T3, T4. With this label, it is appropriate, sufficient enough for you to sketch the cooling curve. Boleh? So nanti your cooling curve akan jadi macam ni lah. Okay, macam ni dia ada berubah sikit, dia ada berubah sikit. So kat sini T1, dia dapat T2, dia dapat sini T3 lah. Macam tu. Pun boleh juga. Okay? Ada yang lain tak? Kalau tak ada boleh habis awal. Saya boleh buat kerja lain.
Doktor?
Yes.
Jadi yang untuk phase diagram tu, katakanlah kita ada empat alloy, adakah temperature untuk empat alloy tu kena sama ataupun boleh buat lain-lain punya temperature?
Empat alloy tu sama maksudnya apa?
Untuk nak kira yang width, fraction tu, kita kena set one fixed temperature untuk semua.
Kan? Tak semestinya. Contohnya alloy yang 20% ni you nak ambil 400 and then of course lah not 400, 600 and then alloy yang apa ni alloy yang 40% ni you nak ambil 200, boleh. Tak semestinya sama. Kalau sama nanti you dapat fasa yang sama, cuma value W je yang berlainan. Okay. For example, one student analyze on 20%, he or she can take temperature of 600 and then another student conduct 40% zinc in aluminium, he or she chose 200 degrees Celsius. So they will get they will do analysis at different temperature. Okay, if you want to select the same temperature also can, but make sure it is practical lah. For example, 20% and 40% zinc ni at 600 is only applicable for 20%, 600. But for alloy 40%, you cannot do the analysis on 600 degrees Celsius because the phase present is only liquid. Sorry anak saya ni bising sangat lah. Sekejap boleh sekejap sikit tak? Okay, soalan lain?
Tak ada
Untuk test 2 dengan final exam pun basically you need to okay, since we are we perform analysis, we perform test, the approach for test and final exam for material science is essay. So if you don't understand this concept, you won't be able to explain it, okay, by words. Okay, for example, let's say explaining cooling curve or explaining phase transformation. It is truly depends on your understanding. Okay, not by following the tutorial. Okay, for example, I show you how to calculate the wave fraction, but you can follow it by calculation. You can show it, but in the way you would like to explain it by essay, it is truly depends on how far you understand. Sometimes students can calculate the value, gain the value, and show the correct answer, but they don't really understand. Okay, if you're required to write it in an essay, you need to really understand. Okay, alright. Ada lagi tak? So my
Okay.
suggestion for you to be able to be really understand this, try to teach your friend or try to explain the solution to your friend. One method is try to present the concept on determining the word fraction ni dalam bentuk video tu, itu melatih kamu lah untuk explain. So if you able to explain it in your own words, meaning that you are truly understand and you can do your final exam or test 2 correctly. Okay? Sorry, tadi siapa nak tanya? Silakan.
Saya nak tanya Doktor.
Ya.
Doktor, yang untuk kalau phase diagram untuk copper silver, Doktor ada tak dalam ni?
Copper
Yang rasa macam ada sebelum ni saya nak tanya. Saya nak tanya yang untuk tadi yang weight fraction tu.
copper silver dan notan.
Dalam
Dan notan
dalam
apa?
dok-
Notan apa?
dalam Doktor content tu pun ada rasa.
Tapi rasanya bukan. Ya. Okay. Apa?
Yang ni. Maksudnya kalau dekat composition yang alpha tu, yang belah kiri tu, daripada 0% silver sampai 8% silver tu,
Yes.
kalau dekat composition tu, kita boleh buat weight fraction ke Doktor?
Composition tu. Boleh.
Temperature mana Doktor kalau kat composition tu?
Yang alpha dengan liquid tu.
Walaupun dia punya composition di bawah 8%.
Bukan. Maksud saya kalau awak pilih alloy ni, awak ambil temperature, kan boleh dapat tu.
Oh, okey. Boleh. Boleh.
See?
Tak
Yeah,
pasal.
first time tak apalah. So sekarang you dah tahu dah. Maksudnya you kena pilih alloy. So the thing is, this method is applicable if you have 2 phases. Okay. You kena ingat tu. Maksudnya sekarang alloy you kat sini less than 8% of what is it? Copper silver. Copper. So if it is less than 8%, the only condition that it has 2 phases is liquid and alpha and beta. So not only at a high temperature, but at the room temperature also you can determine. Okay. So room temperature below 400 also you can determine. Let's say you sketch this. Okay, this tie line. You can start this with here until here. Okay, boleh juga 2 phases tu it can be high temperature and lower temperature. Sometimes the application is maybe I don't know why this method how this method can apply. I mean that the word fraction technique is applicable for processing materials, but I believe somehow it is practical when you want to achieve a certain portion of phases. For example, if you calculate, I don't know because I'm not truly working in the industry. So for example, but it is possible theoretically based on the textbook. Okay, for example, you have 5% of okay, this is the job by if you are working in the R&D or processing engineer. Okay, for example, like this, you have let's say 5% silver alloy. Okay, this is your alloy. You have 5% silver in copper. Okay, let's say this is your alloy. And then you want to determine what is the fraction of phases here at this temperature, 600. Okay, let's say you take temperature equal to 600 degrees Celsius. Right, you can determine how many percent of alpha and how many percent of beta. Remember, alpha and beta consist of different phases, means that the concentration of silver and copper is different. Okay, composition of alpha. Alpha composition is contained, if we read from here, we can see it is about 4% silver and 96% copper. What about beta? Beta we can read through here. So beta, concentration of beta is equal to 95% silver and 5% copper. Okay, so the concentration for both phases is different composition. Okay, one is majority contain copper, another one is majority contain silver. So meaning that the dominant of silver and the dominant of copper shows that this phase at this temperature having different properties, which is dominated by the main composition of that particular phases. So let's say you want a specific amount of alpha phase, how many percent alpha and how many percent beta. Okay, you can decide at that particular temperature, and let's say you want the portion exactly at 600 degrees Celsius. What you can do, you can quench at from 600, you know this is the vessel that you obtain, you can quench to maintain the portion. Okay, but remember, of course, there are several post-treatment needed in order to moderate the weakness of the property after the quenching. Okay, so this is a kind of theoretically can be applied if you want to achieve a certain portion of phases. Okay, but experimental work is really needed. Okay, this is just a theory. So other than that, do you have any other question?
Doktor, saya nak present untuk group 11.
Okay, please, you can present now.
Nampak tak, Doktor?
Okay, nampak?
Kalau saya buka yang ni, nampak, Doktor?
Nampak?
Okay. Kita orang group 11 dapat alloy copper silver. So untuk introduction kita orang dah bincang 3 minggu lepas berkenaan dengan apa yang kita nak buat untuk dia punya engineering application. Kita orang pilih dari penggunaan dia dekat sektor elektronik. So banyak guna dekat wire, dekat electronic components. Mana tulisnya? Lepas tu kita orang bincang juga yang orang PIC yang buat introduction ni bincang juga tahu kenapa copper silver ni banyak digunakan dekat elektronik kan, kenapa tak guna dekat tempat lain. Sebenarnya ada penggunaan dia dekat tempat lain, macam sterling silver kita guna untuk perhiasan kan. Silver 70%, 90%, copper 10%. Tapi kita orang pilih elektronik punya sektor ni sebab kita orang dapat tahu copper silver ni dia lebih kuat daripada copper biasa. Maknanya pure copper punya wire. Pure copper punya wire walaupun dia sangat bagus dalam conducting elektron, dia tak sekukuh copper alloy, copper silver.
Kalau dia punya oxidation rate dia tu siapa yang paling stable? Copper silver ke copper? Pure copper.
Pure copper. Kan?
Dia punya corrosion resistance dia.
Corrosion resistance. Copper silver.
Copper silver lebih bagus.
Dia yang paling gempak kalau kita campur dengan emas lah. Sebab emas punya oxidation level sangat-sangat rendah kan.
Betul.
Sebenarnya yang paling rendah kan antara semua metal yang kita ada, emas. Sebab tu dia mahal. Tapi emas pula dia sangat lembut. Jadi kita guna silver lah. Jadi silver ni kita orang akan fokus dekat dia punya cooling curve. Kita akan fokus dekat dia punya section alpha, beta dan alpha plus beta tu. Tapi kita orang yang menariknya pasal copper silver ni akan diterangkan dekat kita orang punya improvement lah. Sebab dekat improvement ni saya tunjuk je lah dekat Google ni. Ini yang improvement method yang kita belajar kan. Lepas tu minggu lepas ada kita ada borak. Doktor masa kita orang tanya pasal doktor ada borak pasal precipitation. So kita orang study dekat precipitation punya hardening ni. Kat sini saya nak tanya soalan sebenarnya precipitation ni sebenarnya dia yang terjadi disebabkan proses hardening kata. Kan? Maknanya tak kisah kalau kita buat cool balik. Kita buat cool working ke, solid solution ke ataupun heat treatment sekalipun. Dia punya byproduct is precipitation kan.
Apa dia? Sorry.
Maknanya dia punya saya nak kata byproduct, saya tak pasti dia punya terms tu betul ke tak. Maknanya byproduct of hardening punya process is precipitation.
Ya. Okay, dia macam ni. Pure copper soft, kita buat alloy. Okay, we improve the strength. Tapi solid solution, maksudnya kalau alloy sahaja, dia punya strength dia improve disebabkan alloy. And then alloy saja, kalau nak further improve, kita create precipitate dalam alloy tersebut. Alright, so copper silver can produce tapi ni boleh kan precipitation ada ni, copper silver ni?
Ada juga dekat macam ni bukan research paper tapi ni orang panggil ni trademark punya trademark punya paper.
Pattern.
Pattern. Kat sini dia ada bagi tahu yang at what percentage copper plus silver dengan yang macam dia orang guna cool working kan, and dia orang main dengan cross sectional area untuk tengok perbezaan dalam cross sectional versus dengan
exactly precipitation hardening dalam copper silver ni.
Yang mana tu?
Ada ke tak precipitation hardening? Sebab dia tak ada precipitation tu datang daripada mana?
Oh, saya faham. Sebab precipitate ni in definition dia impurity kan?
Impurity. Biasanya intermetallic. Dalam phase diagram tu mesti ada intermetallic. Something like that lah, yang mana kita tahu precipitate ni dia punya properties dia mesti keras tau, hard, very hard, so that they can be an obstacle to the dislocation motion. Okay, normal solid solution unable to form the precipitate lah. It cannot act as a barrier. So make sure in your alloy system able to produce precipitates. Maybe precipitation hardening can be performed in your alloy if provided you put some third elements. Okay, you put carbide for example. You can provide some metal carbide inside your alloy, copper silver alloy. Try search information for that. Otherwise, maybe your alloy is not suitable for precipitation hardening.
Maksud doktor tu dekat kita punya phase diagram macam yang saya share ni, selain daripada kita terangkan dekat alpha ada apa, beta ada apa, kita juga perlu terangkan sama ada dia sesuai atau tidak untuk precipitate punya hardening.
Boleh juga, tapi tak semestinya lah. Saya tak letak compulsory. I mean that for the method of improvement tu, you have to very clear whether the existing copper silver it really can be enhanced their properties through precipitation hardening. Okay.
Hmm.
If you found any reference from any resource, it shows some precipitation hardening performed on the copper silver. Please check, is it pure copper silver or there are other alloying element that promotes the formation of precipitates?
Faham.
Okay, so maybe there are some other third element. Maksudnya it is not just copper and silver, it's contain other elements. Okay, the other elements promotes the formation of precipitates. Kalau tak ada lah. Kalau ada maybe different means that but you have to really ensure it is an enhancement for the copper silver, not um, not silver as a third element, and the other element, which is for example aluminium is second largest amount in the alloy. Okay, meaning that one is improvement for the different alloy, not copper silver.
Faham.
Okay, so make it clear. Biasanya kalau contohnya macam for example lah nickel aluminium. Okay, nickel aluminium is okay because nickel aluminium in the phase diagram in their alloy system, it consists of intermetallic compound. So intermetallic compound, we know if we have this intermetallic compound, we can do heat treatment on that particular alloy. The heat treatment process is aimed to transform any intermetallic form normally obtained normal cooling process. We can modify it, turn it into precipitates. Okay. Asalnya ni biasanya whatever the normal microstructure that we obtain through the casting process, which is slow cooling, we obtain the structure yang similar macam yang saya gambarkan pasal Magnum ice cream tu kan, ice cream yang luar dia ada shell chocolate. That one is normal cooling process after casting. Okay, we have a hard structure of the intermetallic around the grain or along the grain boundary. So inside the grain itself is soft. So if we can change that hard chocolate shell into chocolate chips, which is the mechanical property sama, cuma bentuk berbeza, rather than a shell which is thin layer along the grain boundary, kita tukar kepada dotted ataupun aqueous ataupun particle shape. Okay, then particle shape, the properties of hard is really meaningful for the hardening the materials. Maksudnya sini ini check betul-betul whether dia boleh ke tak.
Faham.
Okay, lagi ada tak?
Itu je setakat ni.
So kalau tak ada apa, okay, thank you so much. Yang lain ada lagi tak?
Okay, dengar jelas tak suara saya?
Dengar. Kamu cakap tu?
Okay. Kalau contoh
Zarif
induk ya betul.
Okay.
Sekejap saya share screen. Nampak tak doktor?
Yes.
Okay, contohlah kan. Saya punya composition ni adalah dekat eutectic reaction. So, kalau dekat cooling curve ni, bawah graf ni dia nak tulis liquid plus alpha plus beta ataupun liquid plus lamella alpha plus beta.
Okay, awak tahu tak apa yang berlaku pada garisan melentang tu?
Sorry, doktor, ulang balik.
Do you know what happened during the constant temperature? The reaction during the constant temperature, do you know what happened? Dia ada masa tu kan, maksudnya constant temperature
lamella alpha plus beta dia mula membentuk.
Okay. So lamella alpha plus beta. So meaning that from the time the beginning of transformation until complete, what is the phases present?
Lamella alpha plus beta.
Okay. So soalan awak apa Sorry.
Maksud saya dekat bawah ni, yang dekat bawah cooling curve ni, nak letak liquid plus alpha plus beta ataupun macam ni. Letak lamella, lepas tu alpha plus beta.
So sekarang you tahu tak jawapan dia apa?
Lamella alpha plus beta.
Betul tak kan? Sebab itu yang berlaku kan? Betul tak?
Betul.
Ah,
Okay.
So, but in the phase diagram, it just indicates alpha plus beta, regardless whether it is in the lamella or in the primary single alpha plus beta as a primary grains. Tak kisah, it just langsam. Tetapi you know exactly at 61.9%, or any transformation passing through the horizontal line, any alloy that consists of a certain reaction, there is a transformation into lamellar structure. Okay, maybe initially there are primary alpha, there are primary beta, but at the end, after it reach 183 degrees Celsius, there are a transformation into a lamella. Okay, means that at the constant temperature, at the isothermal reaction, the transformation into lamella alpha plus beta. Okay, outside that region, outside that range, it won't show any transformation.
Thank you.
Okay, right, good.
Okay. Thank you, Doktor.
Dah siap ke? Yang lain ada tak? Kalau tak ada,
Saya ke Doktor tanya?
yang lain-lain ada lagi tak?
No question, Doktor.
Saya bagi peluang lagi ni, 10 minit. Kalau tak ada, kita tutup kelas kita. 1 jam. Kalau saya tutup terus sebab saya ada meeting lain ni.
Doktor, satu soalan lagi.
Okay, yes. Silakan.
Dekat isothermal reaction Sekejap.
Exploration.
Nak explain tu ada graph ke?
Ada graph, maksudnya apa?
Sebab saya ada tengok juga bila cari isothermal reaction dia mention pasal TTT punya graph. Ke just explain je isothermal reaction tu apa?
Ini masa awak nak explain phase transformation yang dalam assignment tu. Kita nak change TTT diagram is heat treatment process. The diagram that we use for heat treatment. TTT diagram tu. Faham tak?
Ni yang tu point nombor 2 discuss on phase diagram isothermal reaction. Maksudnya just explain je lah. Tak ada apa-apa gambar ajar ke tak ada.
Okay. For example, let's say kalau you have you can gambar aja If for example, if you have a complex okay, let's say this is your phase diagram. All right. Okay. Explain the isothermal reaction. So, based on this phase diagram, you can explain, you can highlight where is the region for the isothermal reaction. For example, you have eutectoid reaction. Oops. Over here. Okay, just explain, for example, this, what is the composition? Percentage of zinc and a percentage of aluminum. And then what is temperature? And then what is the reaction? Okay, the reaction is you write the equation, okay, which is beta, reversible reaction, alpha plus eta. Okay, something like that. Okay, and then what else? Where else? Ada lagi di sini. And then where else? Ada lagi di sini. Okay, so highlight several isothermal reaction observed in your alloy system. Okay, to explain that, you can highlight these three lah. One is the composition. Where is the composition for that isothermal reaction? And then at what temperature and at what reaction? Sometimes you may find in the textbook any isothermal reaction when they identify from the phase diagram, they will write like this: For example, eutectoid, or you give the name eutectoid reaction, okay? And then inside the first diagram, you may obtain beta transform into alpha plus eta. The composition is how many percent? It is about 77% zinc, and temperature is equal 260 degrees Celsius. Okay, this is how they write. Above is composition, below is temperature, and the reaction. They give the name, the composition, the reaction, as well as the temperature. This is the complete set explanation on the isothermal reaction. Boleh?
Macam saya punya lactin kan. So dia liquid alpha plus beta lah.
Yelah.
Okay, faham.
Okay. Tak ada Tak ada dah? No further question. We can end our
Betul.
class. Ya.
Saya nak tanya yang tadi yang soalan yang induk tanya tadi tu yang cooling curve tu kan doktor?
Aha.
Yang kita label lamella tu hanya berlaku kalau lamella tu hanya ada kalau berlaku eutectic kan doktor?
Any isothermal reaction, eutectic ke, eutectoid ke?
Kalau dekat bahagian yang macam saya punya tu yang daripada 0 sampai 8% silver tadi tu, maknanya kat situ dia tak ada eutectic kan doktor?
Tak ada.
Tak ada lamella lah. Kan?
Tak ada lamella.
Okey. Ya doktor.
Cooling curve dia pun tak ada horizontal line, dia tak ada straight line.
Horizontal. Okey.
Boleh?
Boleh doktor.
Lain ada tak? Kalau tak ada, saya boleh habiskan kelas awal. Tak ada No other question? Ramai ni
No.
Okay, kalau tak ada, I think that's all for today. Thank you for